Not great. Had to switch to for this project only, so that's fine. Server would listen to me on my Windows laptop. Okay, okay. Yeah, I had a similar problem when I was using Telnets. I couldn't do it from the command prompt, I think, or the ping. It just wasn't working the same way. Um, and I think Beat said something about protocols. So the command prompt is pretty much looking for a different protocol, and so it's kind of looking at stuff like, "Hey, what is this?" And so sometimes that's why that occurs. But I was testing the code out before I started yesterday, and I kind of ran into a similar problem with that. But I usually use that program for C anyway, so I don't know why I wasn't using it yesterday in the beginning when I tried. But cool, cool. Anybody else have any issues, any bugs, anything? So let's go over approaching the problem here. And I have to stress that we don't need to have 100% understanding on a project in order for us to start or be successful with the project. But we should be around maybe 50 to 90% of understanding, or at least on what the step that we need to take to begin. So with something like this, we should start off, well, step zero, as we talked yesterday, step zero would be to take an inventory. So before we start steps on implementation, we should be taking an inventory. You all can see the repo, right?
Yep.
All right, cool. And so we take a inventory. And so when we say simple web server in C, one of the questions that you may begin to ask yourself is, what is a simple web server? What is a web server in general? And hopefully you know what a server is because we've used the backend prior to coming to the CS portion. But if we start to read the spec a little bit, we can get an answer to what a web server is. And we talked about this yesterday as far as we can make the gets and post requests. We can also update and delete. So any CRUD operation can be built into this thing. And asking questions is a skill you can acquire. So if it's not something that you feel like you're good at now, you can just practice it. And you can get good at asking the right questions. And so one major question is, what is a web server? Okay. And so we can get an answer right away with this one, but some of the questions that we may have may not be so easy to obtain. So whenever you're asking what this question is, you're going to break it down into sub questions. So you start off with, what is a web server? And then your next question is, okay, how can I build that in C? You learned how to build it in JavaScript or Swift and different things like that, where you worked with a backend probably. And so now the question is, well, how can I do that in C? And so with that question, it's a little vague and broad. So it's like, doesn't really nail it down, even if I could get an answer. And so you start to say, okay, well, what's needed for a web server? And so now this question should be a little bit more familiar. So we know with a web server, we normally have some type of listener. We normally have some type of port number, these types of things that you've already did in the back end. And so the question is, how can we implement these things in C? Can I choose my own port number, or do I have to use a certain port number? And so we can begin to inspect the repo as we research the answers to these questions. And we can see here that there is a port 3490 already assigned. Okay. And so that answers the question. And so basically what I'm trying to get you into the thought is that you're going to ask a question that's going to lead to sub questions. And then sometimes your sub questions are going to lead to sub questions. And once we can answer these questions, then we've gained enough understanding on how to move forward. And after 30 or 40 minutes or so, if you have not answered all your sub questions, this is where you would use your resources and reach out to your PMs and say, hey, you know what, I have a question about this, and I'm not sure where to find the answer, or I'm not sure how it's going to work. And that's where we would start to assist you in either finding the information in the spec or answering. And honestly, how I would do it, if you asked a question and I knew where it was in the spec, I would copy that portion, then I would let you know where that was in the spec to find it, in case you missed something else from there. But let's continue with our inventory here. So let's examine what's in net.h. Well, let's kind of do it in alphabetical order because I think it's set up that way. So I'm going to start off where the cache. We don't need the cache. We're not going to work with the cache until sort of tomorrow and Friday. At the end here, I'm going to talk about the cache a little bit because I want to get your minds prepared for it, but we're not going to really implement the cache today unless you are that far ahead in the repo at the end of the day in this time. So let's take a look at file.c. In file.h, the header files, they can really tell you exactly what to expect. So when I look at this, I can say, okay, I got a file data struct, and I have a function called file load and a function called file free. And then I can take a look at file C, and I can take a look, okay, all of this is actually done for us. But what we can do is we can take a look at what functions are available to us, because one of the questions that we should be asking is, what function do I have to create to implement my server, or what function is available to me that I can use in the implementation of my server? And so this is the question we're aiming to answer at this point. So we're going through and we're taking a look and say, okay, loads a file into memory and returns a pointer to the data. So in the real world, in the real world, in an organization, this is pretty good comment. Usually if you're on some type of Geeks for Geeks website or Tutorial Point website, then you'll get comments on every line, but most coders won't comment like that. In fact, you might not even get this. So this is a really good comment. So this is the point where we have to start to read code and understand what's happening. And because when you're on the job, once you get a job in an organization, it's going to be rare for you to be the only developer on a project. You're going to work with many others always, unless you're doing some type of freelance work. So we have to get into the habit of reading code and seeing what it is. And so this is why we want to call our functions file load. So what is that going to tell us? Oh, it's going to load a file. So immediately just looking at the title, as you're naming your functions, we should know what it is. But we probably won't always have a person that gives us good function names. So we still have to take a look at things and read and get an understanding of what's going on here. So we get a quick overview of this here, and we can see, okay, now we're going to free. So it looks like we allocated memory. We used malloc, and it told us up here that we didn't use calloc. So buffer is not null terminated. So we just allocated space. So the space we allocated, each point is not set to null. So if you remember calloc versus malloc, we know that they probably use malloc and not calloc just by looking at this line. At least hopefully you get into that habit. I know that when you're learning, we all know our ABCs all the way to Z. We can probably count to 1,000 pretty quickly. But when you're learning something new, it's still kind of fuzzy. So when you're learning these different programming languages, it's kind of like 1, 7, 3. I know I need a 3. I know I need a 7. I don't remember the order it's going to be, but I know I need these things. Experience is how we make it like numbers and our letters that we have in this working memory that we practiced so many times as a kid. We sung that song, ABC, and it became in our working memory. So for us humans, most of us, we're not like Sheldon from the Big Bang Theory where we're just like, and we got the information. We can't allocate memory like that. It takes us experience. And so experience of coding and things like that is going to allow you to get these steps down to a point where it's going to be like numbers or letters in the alphabets. And so right now we probably know, okay, I'm going to need 3, 5, 15. I don't know the order, but I'm going to need them. And so that's fine right now. And this is why it's probably stressed that you should be having a notebook and pen out, or maybe open up a replit, or open up a side file over here, which is going to be a text, and you're going to spell out your steps. And we kind of spelled out the steps that we would take a little bit yesterday. But you still probably want to do this, to take these mental looks at things and then say, okay, I have access to this file load, and so that I can remember it later. Let's press forward here and let's go. We don't actually need this stuff right now. You probably took a look at it yesterday, but we won't need this. This will be used for our cache. But we can look at the mime type. So we can see mime type get. All right, we're going to get a mime. Let's see. What does it look like? So this is not in your file. And the reason why I put it in the file is because I wanted to show you an example of how to break it down. If you're looking at someone's code and you feel like there's not enough comments there, once again, it's not like, numbers or letters just yet for us. So I still have to look up what this function is and what it does. And so what I'm going to do is I only want to look it up one time. I don't want to have to go back and say, oh, what was that again? So, or write it down. And where's that piece of paper I wrote that down at? So I'm going to go get this here and I'm going to say, okay, this is what this does. C library function. This is the prototype for the function. Searches for the last occurrence of a character in the string pointed to by the arguments. Okay, so this here is my delimiter pretty much, and this is my string, and I'm searching for the period, the last occurrence of the period. All right, cool. And then here, if I actually go up here, I have a helper function. So I can look at this. It says lowercase is a string. That's a pretty good comment. If this wasn't there, I should be able to tell what's going on here because I'm using toLower function. Maybe I have to look up toLower function, but I think it's self-explanatory to where I can remember what it does based off what it's titled. But we're going to the null terminator, and we're going to make everything in the string lowercase. And then we're going to return the actual thing that we received, the pointer that we should receive. So here, we just explained what this is doing. So now I'm going to take a look, okay, what is this doing if it's null? Why would it be null? Well, in my research here, I would discover that this would be null if there was no periods at all. So if there was no occurrence at all, it would return null. And so it's going to tell me, hey, we're going to go to the define mime type. What is that? Application / octet stream. What is that? I've never heard of that one. So I would do some research. Okay, this is another name for bytes. And usually a browser prompts you to download because it doesn't know what to do with it. Okay, cool. Here, this might be confusing here. Why are we incrementing ext here? Can someone tell me why we increment ext? We look at this function. Yes, it's just another name for bytes. Correct, Michael. I think it was in one of the pre-lecture videos, actually, but it's just another name for byte. It's not as common. You're not going to hear it as common, but it's just another name for byte. Yes, it's pretty much kind of like the read the next byte. So if we understand what this function here is going to do, it's pretty much going to give me and then some letters. But I don't want that period in there. Or maybe I don't care about the period. But for some reason, they cared about the period, so they took it out. But for example, here, they just care about HTML. So this is a string comparison. So we're saying, hey, does it equal HTML? Equals 0. We know that if these two are equal, then it will equal 0. And then does it equal HTM? Then we're going to return this. So I could have had the dot in there, but for some reason, they didn't want the dot in there. So they just said, okay, let's move forward to the next position because it's going to return that pointer where it's going to be something like this. And so the pointer is going to point to the period. And so they're saying, hey, go up one, move over one, and point to this. We don't want to point to the period anymore. So that's pretty much what that's doing there. And so we have all of these different return types. Now, if it's null, we have a default type we're going to return to. And these are going to hit depending on which one of these. And then again, you could have had the period in here and then you wouldn't have needed this. But this code is written for, so we're not going to change it. We're just going to work with what is there. And we have all of these types here that's going to return to. If none of these are triggered, then we're going to return to default. So this is pretty much, we don't have a case for this. I might want to have some type of message here. But once again, this is code another programmer has done in the organization. So I'm not going to redo what they're doing. I'm probably going to communicate with them. Hey, would it be a good idea if we added a print statement to show us, hey, we're getting the type that we haven't seen before? Then maybe we want to figure out the best use case for it or a better use case than this default type that we're using. And that may be something that you would ask, you would communicate. So that's a good question to ask. We won't redo our coworkers' code, but we'll communicate, hey, would it be a good idea if we added something like this in? What do you think about this? What other types is possible that we can get? And is there a use case for them other than our default? And so, but we won't change their code. We'll just kind of work with it and maybe jot that question down and ask them later because we're busy doing our own part of the work right now. But let's move forward here to, which one is next? Net.c. So I'm going to look at the net.h first and say, all right, getter in address, getter listener socket. Okay. So we are getting a sockets. And so what is this going to do? So the code is written for us, but virtually what it's doing is it's setting up a listener that handles our incoming connections. Okay. So it's going to set it up our listener. Remember yesterday I told you that we wouldn't have to do this part of the code. And so this part is done for us. Just like it says it's going to be done for us here. And we're just taking an inventory of this because even though it's done for us, there may be a part in the code where we'll have to call that function. Okay, that part might not be done for us, even though the function is done. So we're just taking the inventory. What is this? What is this doing? Okay, and so yesterday we worked with the telnet and we made this response. And so we got a chance to see what a response looks like. And so, and then we also went over the guided project on how to implement this response ourselves. So let's go ahead and move forward here in the repo. So if you're asking yourself this question, we're asking this. Yesterday I stated we wouldn't necessarily have to read these unless we had questions. So if you're saying, hey, what types of MIME types are there? We can go there and we can say, hey, let me go view this and see this. What would be the best thing to use for this case? Because we have different files that we want to be able to work with. And so if you're getting to that point and saying, hey, what should I do here? Then this would have been a great file. But this is something where we would take an inventory. Okay, it's there. I don't necessarily have to read this because these are pretty long files in themselves, but I don't necessarily have to read this. But if I do have questions, I know where to go. And so one of the things that we have to our advantage inside of the networking background is an example of what we needed. And we kind of talked about this yesterday where, just a second, is this it? Yes. So we talked about this yesterday where, okay, this is kind of the big response, but what we would need in ours is pretty much this here. So it's giving us another example here. And then they will actually do the date, but the date's not that important, so it's not a big deal if you have not implemented that portion in yet. Let's just get everything working, and then we can be explicit and give a date on when that connection started. So, and then we also can see our not found. So we can see this response, which is pretty neat because we'll see a function later that says, hey, response underscore 404. So, okay, this is how it should look. Cool. So let's go ahead and go into the assignment here. So we can see we will write a simple web server that returns files and some specialized data on a certain endpoint. And just while I'm looking at this right now, step 3 is no longer needed. If you've already done it, then fine, but it's something that the sprints ahead of you did not actually work with last week. He's removed it, and he gave us that option to remove it this week. So you can skip step 3. You can use it as a stretch goal. I would move on to step 4, and then maybe if you want to do step 3, then you can go back and do step 3. But step 3 is no longer needed. So I wanted to make sure I pointed that out to you. I actually wanted to do that earlier, but I guess that's the perfect time to do it since we just got into that portion of the code. So what do we do next here? So we take an inventory of the steps. So this function is responsible for formatting all the pieces that make up HTTP response, the proper format that clients expect. In other words, it needs to build a complete HTTP response with the given parameters. It should write the response to the string in the response variable. So that sounds familiar. So yesterday we worked with a response and we built it out, and we printed it out first, and then we seen how we can use sprintf to actually provide the response. And so this part of the code was actually kind of provided to you as the beginning. And I believe we talked about this yesterday, that our first step was going to, okay, we need to work with the send response function. But before we can resend a response, we need to build the response. So maybe you didn't know how to send the response, but we should have been able to, okay, this is how we're going to build it. Because it's almost exactly the same. And if should write the response to the string, okay, the total length of the header and body should be stored in the response length variable so that the send call knows how many bytes to send out over the wire. So one question that arrives at this point is likely, hey, what is this response length? I remember content length, I don't remember response length. And so we can continue to read, or you can reach out to a resource at this point. Hey, what's response length is going to do? But if we read further, we're going to see some other things that's going to answer that question. This is kind of a broken link, but pretty much this is where it should have pointed to. So that needs to be fixed. But BG is aware of that. So we have a hint: sprintf for creating the HTTP response, string length for computing content length. And so now it's kind of working with your question that's probably in your mind. Hey, I thought content length and response length is different. And now you're kind of learning that it is something different. And so we continue on. Sprintf also returns the total number of bytes in the result string, which might be helpful. So pretty much what they're hinting at is that sprintf is going to give us the total bytes in a total string. So what does that mean exactly? What they're actually hinting at, if I get to my server.c, is that, and actually the send part is actually done for us. So all we have to really do is build this thing out. But what they're hinting out is this here, response length. We can see that it's got this red squiggly underline, so we haven't actually defined it, but we're going to need it. And that's pretty much what it's saying. Whatever I do with sprintf is going to give me the total number of bytes. And so I could use strlen, and I can concatenate things, and I can say, okay, give me the content length and plus the body, or plus the body, plus the header, and all of this stuff to get my response length. But everything that I put inside of my sprintf function should return the total number of bytes to me, and I can use that in my response length. So that's what that piece of code is saying. And that is a question that you can reach out to a resource for if you didn't pick up on that hint. So if that hint didn't make sense, then you can say, hey, what are they talking about here? And we could also research the sprintf function, which would explain what it's going to return as well. For getting the current time for the dates of the response, you'll want to look at time and local time functions. Both are included in the time h header file. The HTTP content length header only includes the length of the body, not the header, but the response length variable used by send is the total length of both header and body. So this pretty much answers the question that we may have had come up here. It happens to me all the time. We kind of get distracted. We're like, oh, okay, what does that mean as you're reading? And you're saying, hold on, I don't know what that means. And it can get confusing in there. And this is sometimes where we might want to jot down our notes and just continue reading, because the answer may be there, but sometimes the answer isn't there. So after reading step one, if I could not get that answer, then I don't know how to implement because I'm not sure what response length is, then that's when I'm going to reach out to a resource. But because we have that answer, we can move forward. So you can test whether you've gotten a send response working by calling the RSP_404 function from somewhere inside the main function and seeing if the client receives the 404 response. So I believe someone asked me in my group yesterday how we can test the code out to work with. And so they kind of hint to how we can test the code out here. But if this didn't make any sense, then this is also where we would use a resource. but I'm going to kind of show you how we're going to do that. So today I'm going to show you how we can actually test this part of our code out. And so pretty much what we're saying is, before we try to get anything working, let's get a 404 response. Let's get the server up and running, because right now, if you run your server, nothing's going to happen. A student reached out to me and they said, hey, I'm doing the make and nothing's happened what's supposed to happen. I didn't use a Mac computer, so even I had to do some probing. So I reached out to Grant, PM, and he uses Mac, and I said, hey, are these the correct steps on the Mac? And he's like, okay, yes. Then I reached out to Beach and I said, I don't remember this project from when I did it. Is there something supposed to happen in the beginning? And okay, nothing's supposed to happen. All right, cool. Reach back out to the student. That's the steps. And nothing's supposed to happen in the beginning. You have to implement something first. And so, boom. So even us as PMs, we have to use our resources, which is each other and the instructors. And we have to ask the right questions to make sure, because I don't want to just give you the information. Oh, it should be working. Then that's not the right step. So I had to do a little research because I don't use a Mac. I use a Windows computer. But so let's take a look at here. So how can we get this working? So let's start to do some code. I'll leave that alone for now. But let's take a look at this function that they say we can use to test. So it's already done for us. It's already created. In fact, if we take a look at it, we can see send response in here. Can anybody tell me what FD is? Does anybody know what FD represents? File descriptor. That is correct. It's the file descriptor. Where does it come from? Does anybody remember where it comes from? Unix. It's going to come from our socket connection. So it's pretty much an integer that represents our socket connection. So if we had like multiple connections and we're saying, hey, write hello world, it's going to say where to. And then we're going to have this FD that's going to represent, okay, this is where you're going to write this to. So it just represents the connection. It comes from the socket connection. So it's in net.c. It's all this work here. So somewhere down here, we're going to return FD. So cool. Let's do this. MIME type. What part of your code is MIME type? And let's look at let's look at this. Which part of the code is MIME type? If we're looking at this here. Content type. Exactly. It's the content type. So if we remember, if we come back over here and take a look, this is what we're looking for. So it is the content type. Exactly. And so while you're taking this inventory of saying, okay, what does this do? Based off our previous inventory, now we're looking at the 404 function for the first time. We can kind of see, hey, you know what? I understand that part because that makes sense. So hopefully it does. If it doesn't make sense at this point, this is where also you would ask a question and say, hey, you know what? This doesn't make sense. What is this exactly? We get the file data size. What is this part? What's that part? Let's scroll that back up. Which part does this represent? Status code, correct, Michael? So that's our status. That's where we're putting our status at. So it makes sense. So even before you build your send response, you can see this. So if you're having a hard time building the response, this 404 here is going to show you exactly kind of how it works. It's saying, okay, I need this, I need this, I need this. Then you can use the guided project and you can say, okay, you know what? Something's starting to click. And hopefully if it didn't click yesterday, hopefully it's clicking now. But anytime it's not clicking, please reach out. Please reach out. Use the resources. So we can take a look at this here. Okay, so SN printf. I didn't know anything about SN printf. I heard about S printf, what is that? And so pretty much there, it's pretty much just a subset of sprintf. So it's almost doing the same thing, only it just does it a little bit differently. And it's actually considered safer than sprintf. But we could have used sprintf for something simple like this. Our web server is not that complex, but pretty much what it does is it's ensuring that we won't overwrite our buffer, because there's a way that sprintf can overwrite our buffer. And so snprintf ensures us that we won't overwrite our buffer. Also, a question that often comes up is, with all of these types of lines that we need, does the order matter? Can someone help me out with that? Do you know that? Does the order matter? No, exactly. Well, the only part that matters is we have to have our HTTP, our status. Our status has to be on top. Everything else does not matter. So our status will have to be on top, but I can put my content type down here at the end, content length up here, so it won't matter. The only thing that matters is my status has to come first, okay? And that's probably a question that comes, hey, does the order matter? Am I doing this? But how I always do it, because, you know, I just kind of learned that the order doesn't matter. I just followed how I normally see it. Like, all right, I normally see this in this position. I think I helped a student yesterday, and I was just like, oh, well, I normally see it here, so let's put it there. But the order really doesn't matter outside of this here. But as Ian's saying, be consistent. That's pretty much how I do it. This is how I normally see it. That's how I code it up. Cool. So let's move forward. Where am I? So what's next? So we can test whether or not, so let's go back to this part here. We can test whether or not we've gotten the send response working by calling the RSP 404 function from somewhere inside the main function and seeing if the client receives a 404 response. Okay, let's implement that. Let's get our server working at the minimum and get it working. So we take it and look at RSP 404. It looks good. Let's get this working. So where I actually have to go here is to my HTTP requests, and I'll explain why I have to get there as soon as I get caught up in another place. And let's see. Where is HTTP? Cool. So does anybody remember this from yesterday? What two kind of arrays, char arrays did we create? Method path. Correct. So let's create this. Char method 512 get or post char path 8192, and awesome. So read request. So that's already done for me. Great. If it's less than 0, then we're going to do this. And if you're questioning, hey, why is it doing this? Then it's fine to research this function here. And if it's less than 0, it pretty much means that something didn't go as planned. So let's come on down here and handle some stuff. So we need to read 3 components of the first request line. So let's go ahead and reference our project from yesterday. And so we can see, we have %s method path. S represents this here. And I can pretty much look at this and I say, okay, that looks pretty good. I'm going to copy this. I'm going to copy it. Only thing is, I don't have an S. It's called request. So I'm going to have to change that. Cool. And that looks good. I'm going to print out something here. And I'm going to say got requests slash percent %s slash percent %s slash, and then actually I want one more there, and I want to say in, and then we're going to have method comma path. Now I have something in here wrong, so let's see what it is. And put a semicolon. Let's save that. That looks good. There's one thing that I want to do so that I can avoid an error message, and I'll show you guys this trick in a little bit. I'm not using cache right now, so I'm just going to cast this void so that I can get some warnings not to pop up on me. Cool. And now what I'm going to do is I'm just going to call my RSP 404. Let's do it. RSP underscore 404 FD. I'm just going to call the 404 because we're just testing it out right now. Later we'll do something else, but I'm just going to call it right now. I'm just going to let that go. And so, and then of course in here you would want to use send response at some point, but once again, we're just going to test everything works. We're going to work one step at a time. So let's go and test things out. Handle HTTP requests. Let's see. So if I go to the main function, I'm already calling HTTP requests, right? So I don't actually have to add anything in there. That's actually done for me. So that looks good. But my 404 is actually calling send response, so I have to build that out. So let's work on send response. So how is this going to look? How's my send response going to look? We know that sprintf, and I'm actually going to use this here, even though it works the same way. This is a little safer. So I know we didn't talk about it yesterday, and it's not a big deal if you use sprintf. For something like this project, you're not going to need printf too much, but we just implement it because it's part of the solution and it's something to talk about so that we can understand a different method that's a little safer. But how is this going to look? Well, let me do this first part. So of course we know we need our buffer, and then we have this here. So this is actually the size. So we put this size in and it says, okay, this is the max size. So this helps us not overwrite anything. So we don't want to overwrite the buffer. So that's why we have this max size. Without sprintf, we only need the response. And so because you only need the response, you can potentially overwrite the buffer if you have something really large in there. So this keeps us from having that problem. But let's do it. Percent %s in. So what we're doing now is stuff that you should be familiar with. All right, we're creating these new lines. We're creating these connections. I'm not going to worry about the date right now. It's not important to me, but I'll create a spot for it. We're going to do content length %d/n. I'm going to go here /n, go here, and then we're going to put everything in. So can you, which line is the body? So we can look at the numbers here. Which line is my body? Did anybody tell me that? 63. Yes, correct. So we know that we need a blank line and then we put our body. So that is correct. Content type, body. Did I misspell something? No, I did. Oh, okay, good. We're good. Just a little slow catching up there. And so everything else should be done for me here. Let me take a look at the code and let's run the server. So I'm going to make this file and I'm going to get a lot of warnings. So I don't really care about the warnings from other functions, and these warnings should still make my file, but I want to make sure that I don't get anything that should be working right now. So let's go and make it so that I don't have all of these warnings. So one way that I will do this is a void function, but it needs to use FD. So I do that just so that I don't get that warning that I haven't used it, okay? And then here, I need to do this here, void FD, void cache, void requests path. Alrighty, cool. What's going on? Okay, cool. And then here it's going to return the char. So how do we handle that? Well, it's going to return the char pointer. So because it returns the char pointer, I can return null, and that'll get rid of that error message. Okay. FD cache. I've already done this here to prepare for that. And let's make the file again. And I didn't save. Okay, cool. Too many arguments. So it's saying too many arguments. This is line 58. Let's take a look at that and see if we can nail that down. But pretty much I've gotten most of the server C stuff out of the way. So I'm not seeing these anymore. So this is my only one now. So let's see what that is. 58. So I have 1, 2, 3. 1. Huh, they do. They're right. What am I missing? Can anybody tell me? I'm missing something, right? Yes. Awesome. I didn't do that on purpose, but good eye. And I have it in the correct order? Yes, cool. Good deal. So let's make again. So we're gonna make, and then they're gonna give me something right here. I'm not gonna worry about that right now. But let's start my server. So I should be able to do this. Web server, waiting for connections on port 3490. Awesome. It works. Or does it? Let's see. So let's bring over my Postman. You can use curl. I've never really used curl before, so I use Postman. We can use the browser as well. So I'm gonna send requests. Awesome. I actually get the 404 back. So at this point in time in my code, by following the steps, I know that my server works for 404. And so converting this over into working code for other cases won't be too difficult, but I know at least that my send response is doing what it's supposed to do because I'm getting the response. And I forgot to show you this file here. So if we actually go to here, what does this mean? Well, this line means this is the folder to go in. So this folder is connected to there. And if we actually come over here, we can see this server files, 404, and that's the response. So that was my body pretty much that I returned. So just wanted to show you that because I don't think that did, and if I did, sorry. But so let's take a look at it how it looks in the browser. Let's see. We have to go to http://localhost 3490. Wow, there. That looks pretty good. So we know that we've tested our code out and we've done this. And so we know that, hey, you know what? Our 404 response is working, okay? And we're going to take a break, but I want to kind of move forward here because we're almost kind of done with the part of the code that I want to show today. So just please bear with me, but we will take a break. I am noting that right now. I know that we're kind of at the halfway mark almost here. So let's see. So what is next? What would you do next? What steps would you take next? Or what steps did you take next? Did anybody follow this method here that was outlined? Did you test your code at the 404 first? I did not, but I think I need to. Okay, yes. Well, you know, I can't tell you, like, I think I explained this yesterday, like, there was times, of course, like, especially in the web portion where I probably didn't create a plan and I just coded it immediately. And I had, like, kind of a really good time in the web portion because I would stretch all the time. And then I got to CS and it was just like, oh, I better start planning. I learned that really quickly. Like, oh, man, I didn't have to really plan too much when I was doing all this, the first, like, 12 or 15 weeks. But the CS portion was just like, oh, you better start coming up with a plan. And it's okay to have the warnings. Hopefully you're getting an idea of how we can get rid of those warnings. So hopefully that helped. Michael is saying, I didn't get any further than testing. I think I need to retest. I believe I was getting the right response, but I don't remember. Also need to do more planning for step 2. Cool. Create a plan. If you're having a hard time creating that plan, then reach out to someone and we'll come up with some type of way to probe you, see what you understand. If it's a question you can't understand, let's add that to your question list to research. And so let's press forward here. Where am I? So I want to kind of get this working a different way. Now that I got the 404 working, now I want to get it working differently, right? So let's go back to, I believe, HTTP request and see how we can get this working. So now, okay, so let's do this. Let's go HTTP request. And instead of just doing a 404 function, I don't want to do that anymore. If get handle the endpoints. So here, this is like where we would do a check for the get. So we know we can check that because which one is the endpoint, well, it's going to be our method. So we can check gets, we can check posts, and we can do different things based off that. It's not something that I'm really going to code out right now, but I'm just going to give you the kind of gist of everything. So what I'm going to do here is I'm going to comment this out. And let's do response. And we're going to hard code this because it's just about giving you an idea of how this works. All right, so we're going to do text/plain. And we're going to do And here, I think I have what, 9? My name is 9 characters long. All right. And I think that should go away. I'm going to save that and let's see. So first things first is I have to, if you're getting some type of message, like you're getting like connection messages, then you're not actually I didn't want to do that. Let me do this first. I want to show something first. /A/B/C/D/E. We should see that. So we should see that. So after the slash, we should see what's there. We should see our path. So it can kind of tell you how you're going to get access to this path. I wanted to show you that example. So we should get access to how we're using or we can get the path. Now let's close the server. And if you close the server like this, if I go back to this now, it's going to, can't be reached. If I go to Postman, it'll say, oh, couldn't get any response. So that just means your server is not running. So that's how you can quickly debug that. Hey, did I restart the server? So you're gonna have to restart the server. Cool, let's make this and see. And let's go /server. And then now let's do this here, refresh. So now you can see that I'm getting a valid response now, right? So here, now I'm able to get a valid response, okay? And so now let's handle the path, okay? So now I want to say something like strcmp path, and it must equal /Jonathan. And then this is going to equal 0, 0 because we know that that means it's equal if we get that. And we're going to come up here like this. I'm going to come over like that. And I'm going to do an else. Else, I want you to send a 404 if I get a different path. And so your code is going to be different, but this is just to give you the gist of how you're going to kind of make this happen. So, cool. Can somebody tell me what's going to happen now based off this, what I just wrote? What should happen and when should it happen? Anybody? I can put the code back up here. You will get a 404 unless you go to /Jonathan. Correct? Correct. Exactly. So let's take a look at that. Let me slide that over. So 404. Ah, 404. And you probably get the point by now. There we go. And so similar to how we built the 404 response, you can probably make this look really cool if you built your own kind of responses for certain endpoints. So similar to how they did here, server file 404 HTML, built something pretty cool in there. That might look pretty good if you had certain endpoints do certain things. But there's a lot of good stuff here. You got the cats. This should be renamed, by the way. Cat JPG, Beat says it's actually a PNG. So we should actually rename it to cat.png, by the way. So sharing that with you now. So it's named incorrectly. So what's next? What's next? So now that I can get some conditions working, what's next as far as implementation goes? What's the purpose of this slash, right? This path. Getting random number. Okay, so random number is the step three. So step three is no longer necessary. You can do it like a stretch, but it's not necessary anymore. So we can go straight to step four. And so that slash now serves as a point to where we can check to see where tomorrow we will have a cache, but we can check to see if it's in the cache. If it's not in the cache, then we read from disk, and we can kind of go look for a file based off of these things. But we won't no longer have to do the step three. So, and I'm sorry if that's confusion if you've already read that or even started that, but that's something that I learned last night. So so what does this look like? Let's see. What are we gonna do? So pretty much we have to be prepared to get a file of some sort. And you will actually be amazed. But your get file function is going to look a lot like your 404. It's going to look a lot like your 404. So I can actually take this here and I can copy it and I can go to the get file. Where is the get file? Isn't there a get file? Yeah, there we go. Get file and I can, yes. I can get rid of this now. I kind of come down here. I'm going to change a couple of things up, but change a couple of things up, of course. But your 404 is going to look a lot like your get file. Of course, you're going to have to change your path and stuff for valid things. You may not be fetching the 404 HTML file exactly, but you're going to get a request path in here. So we're going to go and try to look for a certain file based off of these things. So it'll look a lot like this, but this is all I'm actually able to give as far as this solution goes for the get file. So this is something that we should be implementing today. So that's one reason why I'm not going over it too much, but it's gonna work a lot like what you've already seen in RSP404. That much I can give you. So let's go ahead and take a 5-minute break, and then we will press forward with questions and some other stuff to prepare your mind for tomorrow. So let's be back by the 19 minutes of the hour, please. Break time. Welcome back. Welcome back. So right now I want to open it up for questions before I move on. And I know that a lot of you kind of say, okay, why do we work on this part when we're not going to have to do it tomorrow? But it is advised to go over the LRU cache just to get your mind in the right set, because I believe that if we, like I was saying, with like ABCs and 1, 2, 3s, you can kind of get, okay, I know how a cache works because we have it on our computers. So when I go to a website, a cache will load up for me, and it will load the website faster if it has it in the cache. If it doesn't, then it's not going to remember certain things, so I have to log in and all of this. But by having a cache, it kind of speeds up things because loading from the disk is slow. So because loading from the disk is slow, the cache can help implement things. I know that part, but I'm not really sure how to implement a cache. So by talking about it today, we can speed up the process. So we can get it from 189, and then maybe tomorrow after we talk about it a little bit more, it can be more of a 1, 2, 3, 4, 5, 6, 7, 8, 9 type thing in our memory. So we're going to talk about the LRQ cache, but before I do so, I want to open the floor for questions regarding what we're doing currently. So is there any questions? Is there something that you don't understand on how to move forward? Is it something that's confusing based off what you've seen? This is the time to ask questions. And if you don't have any questions, then that's going to be assumed that you are ready to implement. You're ready to do this, implement me. So let me share my screen again. If there is questions in the code. Simple question. What is methods chart was handled? So we're just breaking the code down into different parts. So which method do you use? HTTP, let me go to that part. Well, let me go here faster. So what we're using this for is we're going to take the request. So we're receiving the request here. So we're doing this here. We're going to get the request inside of here. So we're going to update the request. So this function is going to receive the requested information, and then now we're going to break it down. So this string here is pretty much saying, okay, once we get to this space or this end of the line break, then I want you to break it into something else. So we're going to break it into this here. So if we look at our server, we have our method broken, and then we have our path broken. So this is what this portion is doing. It's breaking it into two separate strings so that we can do a check to say, hey, is this a GET request? And you may want to have something implemented to where if it's not a GET request, because post is stretch, and we don't have to worry about update or delete, but maybe you want to stretch even that far. But right now we're just handling GETs. And so we're checking the method, and we're going to say, does this equal GETs? If it equals GETs, then okay, let's do some things. We can use string compare for that. So if it equals GET, let's do some things. Then we can check the path. If the path equals this, then let's do some things. So that's pretty much what we're using that part of the code for. And hopefully that makes sense. Or if you have a follow-up question, please ask, Michael. Or just let me know if that does clear it up for you. That sounds fine. Okay, cool. Awesome. Awesome. Any other questions? Cool. I'm going to assume that everybody will know how to move forward then today and everything makes sense. And I guess what I'll do is look at this and I'll share this part of the code so you can review it later. And I am recording the lecture this week because we pretty much have a meeting for the teaching assistants. And so we kind of have a training during the weekend. So they're kind of reviewing the lectures to give us pointers on how we can improve and different things like that. So I passed the video off to them. I did share yesterday's video, but I won't share this video after lunch. So, and the reason why that is because we don't want you to go back and watch the video. We want you to start implementing. And so this is the time where it's like in an organization, you're in a meeting and they talk about, okay, this is what we need you to implement. And there's a time for questions and to gain understanding. And then after that meeting, usually you won't even have that meeting recorded. But after that session, then you're expected to go and do your research and start the implementation. So that's one of the reasons why we don't do the video, because it's been discovered that some students will rewatch videos, and so they're spending more time rewatching the video where at the end of the day they haven't reached MVP because they were rewatching a video or something like that. So, but I may process it again and share it later, like tonight, like during the after hours portion, which after hours I believe is still taking place, but I will check with Jordan. Actually, let me send her a message right now. And Grant and Tim is in here right now. I'm not sure if one of them would want to run that, but I'm going to check with Jordan to see if there is an after hours. And then I guess we can kind of communicate with her if someone else needs to do it. Because I know they're doing the PM in the group that's ahead of us, the sprint group ahead of us. They're doing build week. So I just messaged her now, so I'll kind of figure that out. But so I just shared that portion of the code. Of course, there's a lot of stuff that we'll have to get rid of, like all this void stuff. And you guys can see my screen right now, right? I know I do forget that sometimes.
Yeah, we see it.
Cool, awesome. And so a lot of the void stuff and return nulls will have to update because we just got rid of that stuff so we can not have warnings. But that should be the gist of the code there. And you still have to update things to get it to work exactly how you want it to work. But it should really give you a good leg up today. So if there's no other questions regarding the stuff I just went over, let's talk about the LRU cache, in which we just kind of described why we would use a cache. And it's because loading from the cache is faster than loading from disk. And so if we have something in the cache, then we can kind of implement this way to get things faster. So how is this going to look like? Let me see. I have a file ready to fix. So, okay. Let's do it. I have a server. I'm going to have a cache. And let me make it bigger. I'm going to have a disk. And on the disk, I'm going to have things already implemented, right? So I'm going to probably have index.html, foo.div, style.css, bar.html. All right. And so we kind of talked about cache misses and cache hits. Can someone tell me what a cache miss is versus a cache hit? Miss, M-I-S-S. You're not sure? Okay. I see Pedro typing, so I'm going to see if he has the answer. Where data is not found in the memory. Correct, exactly. So a cache miss is, we went and checked the cache, and what we were looking for is not there. That's a miss. So what would a hit be? Cache hit. Exactly right. It's the total opposite. Data is found. So when we went to the cache, we found what we were looking for. So that's a cache hit. If we don't find what we're looking for, that's a cache miss. And so in your checks, right now we're going to use no for our cache because we don't have to implement the cache right now. And so what we would do though is we would first check to see if it's in the cache. If it's in the cache, then we'll get it from the cache. If it's not in the cache, then we'll have to get it from the disk, but that would be a cache miss. So how this works is, I'm going to start this off like this. I'm going to get index.html. So because when I get this kind of on the server, I'm going to go check and I'm going to say, oh, it's not in a cache miss. So let's go get it from the disk. Because I'm able to get it from the disk, now I'm going to, okay. So she's checking on the after hours. So I'm going to add it to the cache. And so in this particular case, if I do this again, it's in my cache, right? So I'm just going to read from the cache. I don't have to go to disk, which is much slower. So it's in the cache. And so let's go ahead and get style.css. And so in this particular case, I'm checking the cache first. I don't have it in the cache. So I would go ahead and get it from the disk, but I'm going to add it to the cache. And so the next thing I want to do is I want to get full.get. Once again, it's not in my cache, so I'm going to place it in the cache. Awesome. Alec is going to run the after hours tonight, so there will be after hours tonight, and hopefully you guys are using that resource. It's a really cool resource. Even if you feel like you get the material, before I became a PM, I was in after hours, and I would assist people with breaking down their code and debugging. So even before pretty much, I just get paid to do it now. But I was doing it even as a student, and I can't express how much this helping someone else is going to help you. So it just, and not even necessarily just helping someone else, but seeing someone else go through similar bugs. Because sometimes you go through the day, and it's kind of foolish to think this way, but we've all done it. At least I know I have done it. I don't know who else would confess it, but you kind of go through this part where you struggle to get something implemented, and you tell yourself, it's only me. But you'll be interested to know, hey, it's not only you. In fact, some of your classmates are probably having a rougher time than you. And so that experience is just like, oh, it's not only me. Calm down. Cool. Others are having similar problems, or others couldn't even implement this, and I got it implemented. So it's just like, oh, it's not the end of the world. It's not that bad. But as you're doing this, it's a lot at stake. So Lambda invests in us, but you almost invest in Lambda. So you're saying, okay, I'm going to not work a job while I do this. So I'm not going to make X amount of dollars. And the reason why you're doing this is so you can make even more money than you made before then. But to do Lambda school for 8 hours a day, and sometimes you're doing even more hours when you're doing study and things like that, you're investing in Lambda. You're investing that if I put in this work and I put in this time, things are going to work out. And I'm going to upgrade my pay, upgrade my life, upgrade what I can do for my family. And so I would just recommend just taking advantage of every single resource available because you're paying for it, and maybe not now, but once you get that job, you'll be paying for it. So, cool. So we cannot store everything in the cache. We just can't. So because we can't store everything in the cache, there will be some limitations on the cache. There'll be a certain amount of memory dedicated to our cache. So let's just say we have 3 things stored into the cache. How would we update the cache at this point then? So let's say I'm going to get bar.html. And of course, we look into the cache. It's not there, but we've reached our cache limits. How do I go about choosing? How would I update it? Can you think of a method that I can use to update the cache? For example, I can only have 3 spaces, so which one of the items in here would you recommend us overwriting? First in, first out. First in, first out. Yeah, we could do first in, first out. So that's also known as the most least recently used, or the one that's not most recently used. So this is the most recently used, this is the second most recently used, and so this is the least most recently used. So we haven't used this in a while. And so we would overwrite this one here. So first in, this is the first one we got in. So we're gonna just go ahead and take that out, or we're gonna overwrite that spot. So there's a good way to look at it here. So what I would do here now in this particular case is I would overwrite this like this. Okay, but at the same time, now we have this situation where how are we going to keep track of, okay, this was the most recently one added in? What type of data structure could we use to keep track of our cache? Queue. We possibly could use a stack. We probably can use a queue or stack. What else? What other data structure might be pretty good for us? Can you think of another one? A hash. We're kind of getting ahead, but a hash is going to come in necessary and handy. Is this where the linked list comes into? Yes, Michael. This is exactly where the linked list comes into play. So what we have here is we have index.html, and we got it pointing, so it's nothing, okay? And even on that second one, we don't really have to update it. We can just access it. So on the second one, we're still here. Then on the third, when we have style, we're going to point to style.css, right? And then when we come to the next part here, now we're going to work with foo.get, okay? And so now at this point in time, we're going to work with bar, and so we can pretty much access the head here, and we can say, all right, let's overwrite the head, and let's make it bar.html, and we'll have the rest of this like this. And did I do that right? No, I don't think that I did. Let me see. And so we can have it like this here. And so does anybody remember the time complexity to update our head in our linked list? What's the time complexity for me to overwrite this index HTML to bar HTML? Big old time complexity. How many operations is necessary for that? Because we know our linked list has a head, right? It's going to have this pointer to the head. So how can we overwrite the head? Anybody remember the time complexity? Nope. So it's O1. O1, so it takes us exactly one operation. We can just access the head and we can say head now equals bar.html. It takes us O1 operations to access that, which is pretty good. So we like that. But let's say that we have a pointer and it's saying, okay, now this isn't, so we just added bar HTML. So this isn't the least most recently used. Which one is the least most recently used? It's going to be this one, right? But then what if we got to the point where, so let's add something in real quick. Get style.css. No, I don't know if I want style. Do I want style? I already have style in here, so let's see. I have index. So let me do index. And so how this is going to work is I need to update this portion of the code, the index.html. And so now at the end here, if I have another thing that's not in the cache, I will have to update this. How many operations, or what's the big old time complexity to get to the end of the list and to update it for a linked list? What's the big old notation to update something that's at the end of our list? We need to remove that, swap that out with something else. ON, correct, Stefano. So it's ON. So we don't really like ON too much because we know we could get O1. How could we get O1? Time complexity. How can we swap that out? What data structure would we might have to update to? Now we're using a regular linked list right now. Hint, hint on the regular. How could we change this to O1? We could probably do something where we keep track of the head, right? And we can keep track of the tail, but that in itself would not do the trick because we would still have to, if we had like 5 or something in here, we would still have to go travel backwards to get anything that's in the middle. Right now it's 3, so it's not that bad, but so just having the tail pointer itself would not work. We would need some kind of next and some kind of previous, right? What data structure is that? Doubly linked list, correct. So the doubly linked list would give us big O 1 to remove from the tail and add to the head, or remove from the head. So we could do everything in O1. So we could add the cache miss to head of lists in O1. And then we can remove LRU from end of lists in O1. So that's the time complexity we like. We love it. But how can I check my cache now? Now that I have this linked list, I have this issue where I need to find out if the item is in the cache. So for example, right now, let me change this up here. So we have var index foo. So let's put index here. And so now I'm going to add in style.css. So it's not in our cache, but how can I check if it's in our cache? And what's the time complexity for checking if we have the file in our cache? So the worst case scenario is that we do a check on everything and it's not even there, right? So what's the time complexity of something like that? We're searching to see if it's available. O(n) squared. It's not quite O(n) squared. So what I'm going to do is I'm going to start off at either the head or the tail, and then I'm going to go to the next item until I reach the tail. And if I find the item, then I'll stop. But if I don't find the item, which is the worst case scenario, then I have to go through the total length of the linked list. O(n), exactly. It's going to be O(n), where n represents the length of our linked list. So cool, or maybe not so cool. Is there a way that I can access my data faster? Can I get O(n) time complexity to find out if something is in the linked list? Is there perhaps a data structure that I could use? Sean, I think you were a little ahead of us here. Hash table. Yes, how would that work? How can I use a hash table? Oh, wait, I have a linked list. I can use a hash table that's separate data structure. How is that going to work? What would be my key and what would be my value if I implemented this hash table? Anybody? So we know that hash table works with key value pairs, right? What would be my key? What would be my value? And this is a very realistic problem that you will have when you're working in an organization where like, oh, that search is not fast enough. To remove is not fast enough. And this is why we learn about data structures. So what would be the key and what would be the value? Just take a guess. The file descriptor as the key. So we could use, and I'm not sure if you mean this, but our file descriptor, the FD that we normally is an integer. In this particular case, we would use the name. So index.html would be my key. So my title of file would be my key. Because if you remember how we hash, how's the hash function work? If we have this string, then we can change this string into ASCII numbers, each character. We can add that up to a sum. We can use the module to convert this into an index in our hash table. And then what would be the value? So we have our key. So we would use this for our key. And this would pretty much be like in Python, you would see this where it would be like hash table index.html. But what would be the value? And I'm kind of using these to point to something. So what would be the value? Index. So our titles is going to give us an index. So when we use our hash table, we have this hash function that's going to provide us an index in this array almost, data structure type. And so we would actually use the pointer in our linked list as the value. So we can check to see if index.html is inside of the linked list by using a hash table data structure. And we can then now search in O1. Time complexity. So we can find out if it's in there really quickly, because it's either going to return a valid index or it's going to find the thing that we're looking for quickly, or it's not. So we can say, if I'm going to add, for example, right now, this is my cache. I'm going to say I'm looking for foo.gif, and it should give me exactly the value. It should give me that. Or it's going to return null because it's not in there. So we haven't set a value for it. And so if that's not null, then we have our value. And if it is null, then it's not in there. So then we can say, okay, I need to go to the disk now. So our search can be implemented with O1 time complexity by using the hash table, which has a key using the title of the file. The value would be a pointer to the linked list. And so it's kind of pretty cool and maybe even mind blowing in a sense, because we kind of use data structures like how, all right, we're using a hash table this week. All right, we're using a linked list. And now we've combined two different hash tables, two different data structures, I'm sorry, to increase the time complexity for our overall functionality. And so we saw one problem with the linked list and said, okay, if we use a double linked list, then we can get O1 from the front and the end. But we still had ON operations to perform a search. Okay, if we add in a hash table and use the titles as our keys, now we can get O1 search, which is pretty much the best of both worlds. So hash table has its functionality that provides us some really good things, but we can't go to the next item very easily with a hash table. Linked list provides that. We can go next, we can go previous with the double linked lists. And so now we use the hash table because of its search time complexity. And so by combining both data structures, we get a more optimal experience, which again is very real world like, because you will be on a job where they're saying, hey, we need this to be a little faster. We need this to work a little more efficient. Or maybe something is breaking because it's so slow or not working correctly. So that is all I have for LRU Cache today. And I will send this out like this. Does anybody have any questions? Not yet. Okay. Well, not yet. I'm going to hold you to that, Sean. And if you do have a question, please reach out to me. And I would, I would take another, after lunch, I would take another 30 minutes to devise the plan that you're going to do today. So, what am I supposed to do today? And so, how I would answer that question is what I'm supposed to do. I'm supposed to get a file working. So I'm supposed to gain access to files today. I would also ask the question, what can I use or create to help me? And so since we're working with files, once we examine the code here, we remember file C. So we had some kind of file load, file H in there, and then we look back at the server and take a look. Okay. So we may have to kind of load a file. We may have to do something like that. It's possible. Okay. We can also think, okay, what type of functions, what type of built-in functions can I use to do the thing I need to do? And so this is where, okay, are we going to be using sprintf or scanf? So are we going to have to parse something? Or are we going to have to save a variable? Are we going to need to gang the length of something, know the length of something? So maybe we're going to use string length, or can we use printf again in the same manner that we used it when we build out our responses? You're going to ask these questions, and it's going to be followed up with more questions. And when you get to the point where you don't have another question, then we should make sure we have all the answers. If we don't have all of the answers, then this is where we want you to use your resources. So ask plenty of questions and use those resources. And if you do so, I think that you should have a better time at it. Once again, we've all been there, but this is one of those projects where planning things out is the most realistic to getting the job done. And this is very realistic project to how you're going to code. Sometimes you're going to be looking at someone else's code, and your job is to figure out the bug. There's some bug in there, and you got 1,000 files, and they're like, hey, there's a bug, but we don't know what the bug is. And it's your job to figure out what the bug is because we're paying you. And you have to go read people's files, and you have to do this. And so questions you would have to ask is just like, okay, well, what's the bug? What's happening exactly? And you troubleshoot it. I think Kat asked a great question yesterday where she was like, well, how do I figure out what layer is on? And so we're checking connections and different things like this. And these are similar questions that we're going to have to ask as we figure out what we're going to do today and gaining understanding how we can implement a solution today. So please consider that. Please consider that. I want everybody, at least in my group, but maybe the other PMs will ask this of you. I would like to see, after 30 minutes of reviewing the code, I want to see 5 questions. DM me 5 questions, 5 questions. Everybody that's in my group. I guess your PMs can let you know if they want you to do this as well. DM me 5 questions that you had about the project before you got started as you were skimming over things and the answers. And even if you don't have the answer, give me the 5 questions and I can help you get the answer to the question that you don't have the answer to, so that we know that everybody has the understanding to move forward. So that is the game plan for today, making sure we're asking enough questions. And so that's what I want to kind of measure as attendance at this point. So ask these questions for yourselves. If you can't find the answer, let me know. And we're going to take exactly 40 minutes to do our research on our own and build our questions. And at that point, you should be reaching out to me with either your questions and answers or partial questions and answers. And then like maybe there's a couple of questions that you don't have the answer to. And then we'll probe and we'll research together and figure it out. And so we can get you guys started. I also want to see a plan. What's your plan today? What function do you need to implement that you have not implemented yesterday? And how are you going to go about that plan? So those are the questions that I want. So 5 questions with answers, or just questions. Take 40 minutes after lunch to get the answers and develop your questions. Send to PM. Other PMs can participate, though, if they want. Also want to know your plan for today and how you, and what steps you will take to get there. All right, cool. And here is the thing where we can't contradict ourselves. You either have something to implement or you have a lot of questions. It can't be both. So if you don't know how to implement, one of the first questions is, well, how do I implement this thing? What's going to be needed? And this and that. So we either have something to implement and we are diving right in, or we have questions. So it's either one of those two things. Does anybody have any questions at this time before I let you go for lunch? All right, I will let you go. Have a great lunch. Good luck today. Happy hacking. Enjoy your day, everyone.